All right, if you've made it this far, congrats. This one is not going to be any better. I'm literally sorry. All right, let's do some rearranging real quick. Otherwise, this is not going to make any sense. So first things first, this is a fraction. We should write it so it looks like a product. Okay? Awesome. I'm actually going to go one step further and write it like this. I'm going to write r squared times r over square root of 4 plus r squared. Now, if you're like, Meg, I would never think to do that. Honestly, neither would I. Let's just do the problem and just get it over with, okay? The reason we do this is because if we only kept it like this, it's gonna get ugly really fast. Again, I know this is not like an obvious re-representation, but let's just roll with it, okay? As long as you agree that these are all equal, I'm happy. All right. Let's figure out our u and our dv. All right. What do you guys think? I'll give you a second to think. It's like Blue's Clues. No, it's like Dora. You guys know who Dora is, right? What do you think? All right, time's up. We're going to take u to be r squared. Again, usually you're going to want to go with your polynomial term as your u, okay? Just trust me on that one. And then that makes dv everything else. This looks scary for a dv. Again, stay with me, okay? Don't click off yet. All right, du is going to be 2r. V. You're not going to like this, but let's do it. Antiderivative of r over square root 4 plus r squared. Now, listen, I've been doing integrals for a while. I've been teaching integrals for a while. So, I've been doing this for a bit, so I can kind of just see how it's going to work out. But this is what I can say. I have an r squared here and I have an r here. I see a function and its derivative, kind of. That screams u sub to me. I see a function and its derivative. Okay. So let's plug everything in. So let's see. I get integral, I'm for sure this, and then I'm 1 plus, let's figure out what dr is. Dr is 1 over 2r du. Okay. Wait, let me put this r back here, my bad. Okay. You know you did your u sub correctly if all your r's cancel. Boom. They did. Life is good. Okay. So we get integral 1 over square root u times 1/2 du. Either way, this is good u sub practice too, because you do need to know how to do that. What can we do with constants? Boom. And I'm going to rewrite this as, well, there's kind of a process here. This is the same thing as this, which is the same thing as this. Okay, hopefully that's not super foreign to you. And if it is, well, I'm sorry. All right, so now we're just taking the antiderivative of this. Okay. Let's see. So to do that, we need to use this. Okay, so I increase my exponent by 1. I divide by that new exponent. Okay, which is just this. Okay, 1/2, 1/2 cancels. So we get u to the 1/2. Let's plug our u back in. Okay, yep, that was just for the initial v. But now you know how to do u sub, I hope. All right, I'm gonna erase this. You can obviously just roll the video back if you need to. Awesome. Okay, great. Now we're ready to do u times v minus integral v du. Okay. Also, it's not going to get any better after this. I'm sorry. All right. So our original integral. Also, you should just put me in 2 times speed at this point. I'm sorry that I'm yapping. Okay. U times v gives me r squared times 4 plus r squared 1/2. Yeah. Minus integral 4 plus r squared 1/2 times 2r dr. All right. Let's just do this, okay? Please. Anytime you see a constant, just put it in the front of your integral, for God's sake, okay? All right, you're probably like, Meg, this integral doesn't look any better. You're right, it doesn't. But I see a function and its derivative. What does that scream? Everyone says in unison, u sub. Okay, so we're going to take u to be 4 plus r squared because its derivative is 2r dr, which we kind of already did this. Dr becomes this. All right, so let's rewrite everything like that. So we're going to have, let's see, u to the 1/2 times r times dr. Okay. Our r's are going to cancel. That's good news. Let's bring that 1/2 out in front. So if I have 2 times 1/2 integral all of this, what happens to those 2's? Yep. You got it. All right. So we're here. Minus u 1/2 du. Hopefully this isn't so bad now that we're here. So using that antiderivative piece, we'll have u, what, this? I think so. It's looking right, I think. Okay, no. Sorry, I got distracted. All right, well, what's u? That's u. And this is the same thing as 2/3 multiplying this. Okay, we're so close to being done. Now we just need to evaluate from 0 to 1, which, again, you know that I'm not going to do this for you, but allegedly you should get this. I think it's a 2, yep, okay. or something. Honestly, just plug this into a calculator, get the decimal, and see if you get the same one, okay? Yeah. All right, I think we got one more to do in the next video. Oh, where to go? I'll find it. All right.